Hello, my name is Lisa.
And I am Mark. Welcome to a new episode of GeoVoices, a video program sponsored by Vols, GeoConsultant.
Today we will discuss an article from Science Daily titled, "Breaking Ground, Could Geometry Offer a New Explanation for Why Earthquakes Happen?" The article discusses groundbreaking research led by Brown University that challenges traditional beliefs about the causes of earthquakes. The study, published in the journal Nature, suggests that the alignment of fault networks, rather than friction, plays a critical role in determining where and how earthquakes occur.
The research team focused on the geometrical makeup of rocks in fault zones. They argue that the traditional view, which emphasizes friction as the primary cause of earthquakes, is incomplete. Instead, they propose that the way faults are aligned, considering complexities such as bends, gaps, and stepovers, significantly influences seismic activity.
The study utilized mathematical modeling and data from the U.S. Geological Survey's Quaternary Fault Database and the California Geological Survey. By examining fault zones in California, the researchers developed a model that accounts for the geometrical intricacies of fault networks. This model suggests that the alignment of faults can either facilitate or hinder the smooth sliding of rocks past each other, which in turn affects the occurrence and strength of earthquakes.
To illustrate their finding, the researchers use the analogy of serrated teeth on the edge of a saw. Faults with fewer or less sharp teeth allow rocks to slide past each other more smoothly, leading to a phenomenon known as creep. In contrast, faults with more or sharper teeth are more likely to lock and then release suddenly, causing an earthquake. This analogy helps to explain why some faults are more prone to seismic activity than others.
That is very interesting, Mark. But before we continue, let us have a short break to let our viewers know about Vols GeoConsultant's YouTube channel.
My name is Ricardo Valls. I am a professional geologist registered in the province of Ontario, Canada, and also the president of Vols GeoConsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 550 videos.
Thank you, Lisa. The study's findings have significant implications for earthquake prediction and understanding. By focusing on the geometrical properties of fault networks, scientists may be able to better predict where earthquakes are likely to occur and how strong they might be. This new approach could complement existing models that emphasize friction and provide a more comprehensive understanding of seismic activity.
Sai, one of the lead researchers, emphasized the need to test this model beyond California to see how well it holds up in different geological settings. The team plans to apply their model to other fault zones around the world to validate their findings. If successful, this could lead to a paradigm shift in how scientists understand and predict earthquakes.
Victor 100. Sai, one of the lead researchers, emphasized the need to test this model beyond California to see how well it holds up in different geological settings. The team plans to apply their model to other fault zones around the world to validate their finding. If successful, this could lead to a paradigm shift in how scientists understand and predict earthquakes.
In summary, the research led by Brown University offers a novel perspective on the causes of earthquakes by highlighting the importance of fault alignment. This new model challenges the traditional friction-based view and opens up new avenues for research and prediction in seismology. The study underscores the complexity of fault networks and the need for a multifaceted approach to understanding seismic activity.
In summary, Liz, the research led by Brown University offers a novel perspective on the causes of earthquakes by highlighting the importance of fault alignment. This new model challenges the traditional friction-based view and opens up new avenues for research and prediction in seismology. The study underscores the complexity of fault networks and the need for a multifaceted approach to understanding seismic activity.
This research not only advances scientific knowledge, but also has practical implications for earthquake preparedness and risk mitigation. By improving our ability to predict earthquakes, we can better protect communities and infrastructure from the devastating effects of seismic events.
And that is all for today's video. Don't forget to like and subscribe, and tell your friends about Vols GeoConsultant YouTube channel. Have a great day.
Goodbye.
Welcome to GeoVoices, your go-to YouTube channel for concise and engaging videos on geology and the latest geological news. Whether you're a seasoned geologist, an earth science student, or simply an enthusiast, GeoVoices offers insightful content that caters to a diverse professional audience. Stay informed with our expertly curated updates on groundbreaking discoveries, innovative research, and practical insights from the field. Join our community and enhance your geological knowledge by subscribing to GeoVoices on YouTube, GeoVoice.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.